All right, our next topic is going to be rounding. So whenever you take a measurement, it's always going to have a certain number of significant figures, and then that number of significant figures is going to tell you something about the accuracy of that measuring device. So let's say, for example, that you measure something and it turned out to be 0.2 meters in length. And the device that you used to measure that was a meter stick. Now, if you remember, the meter stick was, the numbers on the meter stick was the centimeters, and there were 100 centimeters in 1 meter, but you could be more accurate than just reading it to the centimeter number. You could also use the millimeters. So that this number here is really not as accurate as what you really were. So if you were using the meter stick and it was exactly 0.2 meters, then it was actually 200 millimeters. So 200 millimeters is the same thing as 0.2 meters. Well, if I had gone with this one, this would be one significant figure, and then this would be 1, 2, 3 significant figures. So this is what you really ought to be telling somebody when you're telling them what the length of the object was. So you would say that it's 0.200 meters, and then this is good to 3 significant figures, and then this is good to only 1 significant figure. Well, if having 3 significant figures is good, then why didn't you just say that it was 0.200000? So if 3 is good, then 6 is even better. Well, if you tell somebody that something was this long, you're implying that you had a measuring device that was capable of going out that far. And so you don't want to misrepresent your data. So you only are going to use the number of significant figures that are allowable with your particular measuring device. So here are some examples of how many significant figures do you have. So the first one is going to be 96,000 grams. So 96,000 grams. And then the question is, how many significant figures does it have? Well, if you have zeros on there, you are to assume that you used a measuring device that was that good, and so you have to include those zeros on there. So therefore, it's going to have 1, 2, 3, 4, 5 significant figures. Okay, now let's say though that your measuring device was not that good, and your measuring device was only good to 3 significant figures. What could you do? You could write it in scientific notation. So if you put the decimal point right here, in our previous lesson we learned that this is equal to 9.6 times 10. Okay, here's where the decimal point used to be, and we're going to move it 1, 2, 3, 4 so that we have that. So this would be good to 2 significant figures. If we put an extra 0 on there, then it's going to be good to 3 significant figures. So that's how, to be very, very precise, you can write numbers in scientific notation, and then that explicitly is going to tell how many significant figures you have. Okay, what about though if we go to the second one there, which is going to be 0.044. Okay, now this one, this 0 here, that is not going to be significant, because what it's doing is it's just holding the decimal point there. It's telling you where the decimal point is. This one is also not going to be significant, because we could write this thing in scientific notation 4.4, and then it would be 1, 2. So 4.4 times 10 to the negative 2. And so now you can plainly see that that only has two significant figures if you were to write it in scientific notation. Okay, what about though, so let's just, I'm looking over here to the one that says 5.009 and meters. And so how many significant figures does that one have? Now notice that this time these zeros are important because they're holding the 5 and the 9 away from each other. So they are going to be significant, so that this is going to be 5, 1, 2, 3, 4 significant figures. So I'll let you go through that chart and look at those various numbers and make sure that you realize why it has a certain number of significant figures. Now, we want to also be able to add and subtract numbers that are in using the correct number of significant figures, and we also want to be able to multiply numbers that are using the correct number of significant figures. So let's take a look at the first one. There is an example of multiplying numbers together. And so you are going to be multiplying three numbers together, but the problem is that they have different numbers of significant figures. So the 12 has two significant figures, and then the 1.045 is going to have four significant figures, and then the 338 has three significant figures. So what are we going to do? Well, the first thing is multiply all of those numbers together on your calculator. Then you're going to round the final answer down to whichever number had the least number of significant figures. That means that your entire experiment is going to be controlled by the lousiest piece of equipment that you've got. So whatever piece of equipment has the least number of significant figures, so that means it's the least accurate measuring device, then those numbers are going to control the outcome of the experiment. So that in this particular one, that 12, which only had two significant figures, is going to be controlling everything. So whatever answer that you get, you're going to have to round it back down to two significant figures. You have to get rid of them. Okay, now what about if it's addition and subtraction? So in the case that you got there, you're going to take 89.453, and then you need to add it to 2.5. So it's going to be a little bit different than when you do it with multiplication. So we're going to line up the 2.5 with the 89.453. So we'll put the 2.5 there, and then we're going to again add them together, and so when we add them together we end up with 91.953. Okay, and then we need to round it to one significant figure over here. So there's only one number on this side of the decimal point, so that means that we need to, now there's a special technique if you have a whole bunch of numbers and you're rounding them. So normally you always round up. So if this is a 5, then you're going to round up in that case there, and so then this turns out to be 92.0. But if you have a whole bunch of numbers, what you're supposed to do is half the time round up, and then the other half of the time round down, and then that gives you a better representation of what the correct answer ought to be. So this one had was rounded to over, the decimal point was over to here, and then we're going to do the same thing here. Now, in most of my classes, we never add and subtract numbers, so this one isn't such a big deal as the multiplication division one. But that's how you're going to round numbers. Now, in my classes also, I'm not such a stickler for rounding, so most of the time, the numbers in your textbook are going to be to 3 significant figures. So that means that whenever you are multiplying or dividing numbers, just take that answer and round it to 3 significant figures. And that's going to be good enough for me. But if you want to be really precise about it, you're going to use these techniques to do it. All right, so our next topic is going to be on geometry. So I'll see you in just a moment.